Good day, viewers. You are welcome once again to our online teaching series. Today, we are going to take a look at a very simple problem in chemistry. With example, we should discuss isomerism. With examples, discuss isomerism. Now, let's do this together. Isomerism. Isomerism is actually a phenomenon whereby compounds have the same molecular formula the same molecular formula but different structures. Classification. How do we classify isomers? Classification of isomerism can be classified into basically two. Number one, structural isomerism, and number two, we have what we call stereo isomerism. Now let's quickly take a look at the first one, structural isomerism. In structural isomerism, you see compound have the same molecular formula, but the arrangement of the carbon chain within the molecules are different. Now the structural isomerism is further divided into one. We have chain isomerism. Two, we have what we call position isomerism. And three, we have what we call functional isomerism. And finally, we have what we call metamerism. Now today, let's take a look at chain, position, and functional isomerism quickly. Now in chain isomerism, chain isomerism, in chain isomerism, we talk about the arrangement of the carbon chain in the molecular structure of the compound. Now let's take an example. Let's take a look at the hydrocarbon called butane. Butane is an hydrocarbon. It belongs to the alkane series, homologous series of the alkane, with a molecular formula of C4 and H10, written as C1, C2, C3, C4, H1, H2, 3, 4, 5, 6, 7, 8, 9, and 10. So you can see that we have 10 hydrogen atoms to 4 carbon atoms rather. Now, what we have here is butane. Butane can also be written as 1, 2, 3. And somewhere around here, I have a CH3 group. Here, H, hydrogen, 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 and here another hydrogen. If you take a look at it, you find out that we have transported this methyl group has been shifted to the second carbon atom, which is what you have here. So what we have here now is carbon number 1. If you start the counting from both sides, you see that at either end you start from, the central carbon still remain carbon number 2. So if we take it by here at carbon number 2, we have a methyl group. What I have here is 2-methyl propane. 2-methyl propane, in the sense that this methyl group has been shifted to the second carbon atom here. So now if you take a look at it, the methyl group is attached to carbon number 2. So what I have here, 2-methyl, then 1, 2, 3 propane. So you can see that what I have is 2-methyl propane. It is an isomer of normal butane, because if you count the number of carbon atoms here is 1, 2, 3, and 4. And you count the number of hydrogen atoms, you also have 1, 2, 3, 4, 5, 6, 7, 8, 9, 10 hydrogen atom. So what we have here now, this is called chain isomerism. Another example can also be seen in pentane. Pentane has three isomers with molecular formula C5 and H12, written as C1, 2, 3, 4, 5, with hydrogen atom. Look at it, 12 hydrogen atom. Now, if you take a look at it, 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, and 12. What I have here is normal pentane. Now, pentane can also be written as 1, 2, 3, 4. Here now, this one has been moved. Take a look at it. This methyl group has been moved down to the second carbon here. So here I have a CH3 group, which is a methyl group. Here, hydrogen, hydrogen, hydrogen. Hydrogen here, we have hydrogen. Now, what I have here is, you can see that all this side, what we have is hydrogen atom. So what I have here now is an isomer of the normal pentane. You can see that I have one carbon atom here. Look at the carbon atoms. 1, 2, 3, 4. Here, the parent chain, we have 1, 2, 3, 4, 5. But here in the parent chain, we now have 1, 2, 3, 4. Now, the methyl group is attached to carbon number 2. What I have here is 2 methyl. 2 methyl in the sense that a methyl group attached to carbon number 2, 2 methyl, then we have 1, 2, 3, 4, butane. So 2 methyl butane is an isomer of normal pentane. Also, this can also be written as 1, 2, 3. Now here we have 3 carbon atoms. Here I have a CH3 group. Here another CH3 group. Hydrogen, 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 here hydrogen, another hydrogen. So you can see that we have two chains here, one methyl group, a second methyl group. So what I have here now, if this is my carbon 1, carbon 2, and carbon 3, on position number 2, carbon 2, we have 2 methyl group. So what I have here is 2, 2 dimethyl propane. 1, 2, 3 propane. Now, what I have here is an isomer of pentane. Now, quickly, let's take a look at position isomerism. In position isomerism, what do we have in position isomerism? In position isomerism, there is just a shift of the functional group from one point to another. A shift of the functional. Let's take a look at an example of position isomerism. Let's take a look at butanol. Butanol, I have C1, C2, C3, and C4. Butanol is C4, sorry, C3, C4, H9, OH. What I have here is butanol. Now, can be written as, here we have OH group, which is this OH, one carbon, two hydrogen, three hydrogen, four hydrogen, 5, 6, 7 hydrogen, 8 hydrogen, and 9 hydrogen. What I have here is normal butanol, but the hydroxide group you see here is attached to carbon number 1, OH. So it can be called butan 1 or butan 1 or. Butan 1 or in the sense that the OH group is attached to carbon number 2. Now, this is an isomer of another one, butan 2-or. 1, 2, 3, 4. Here, shifting the OH group to the second carbon. I have here H, H here, H here. Now, here I have OH group. The OH has been shifted to the second carbon here. Here, hydrogen, 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 and another hydrogen. If you take a look at it, the number of carbon atom here is 4. The number of carbon atom 4. The number of hydrogen atom here is 10. Number of hydrogen atom here is 10. And 1 hydrogen atom. Here, what we have here now, we have butan 2-ol. Butan 2-ol. In butan 2-ol and butan 1-ol, the difference is just the position of the functional group, which is the OH group. The OH group shifted from carbon number 1 to carbon number 2 here. So what we have here is called position isomerism. And finally, let's take a look at the functional isomerism. What happened in functional isomerism? In functional isomerism, you find out that the atoms have the same molecular formula, but the functional group inside of them is different. Now, let's take an example of functional isomerism. Take a look at the atom. Let's take a look at this atom. This compound, ethanol. Ethanol can be written as ethanol. The formula for ethanol is C2H5OH, written as C1C2H5 here. This is H5, and you have here OH. This is ethanol. Is it the number of carbon atom is 2? Hydrogen is 6. 5 here, 1 here, 6 with 1 oxygen atom. This now is an isomer of another compound called dimethyl ether. Now, dimethyl ether has a different functional group. The functional group present in ethanol is the OH group. Look at it. While in dimethyl ether, you have a methyl group CH3. The functional group is X attached to another CH3. So what I have here is dimethyl ether. Dimethyl ether belongs to the functional group called the ethers. While here, OH belongs to the functional group called the alkanols or the alcohol. Now, if you count the number of carbon atoms in both of them, 1, 2, 1, 2. The number of hydrogen atoms, 3, 3, 6. 1, 2, 3, 4, 5, 6. You can see, and 1 oxygen atom. The both of them are called functional isomers. And another can be found in propanol and propanol. Let's take a look at propanol. We have propanol. Propanol is written as CH3. You have C, double bond O, CH3. And we have propanol, written as CH3, CH2, C double bond O, H. Now, what do we have here? Take a look at it. Now, if you take a look at this now, this has the functional group of the alkanals or the aldehydes. Here we have the functional group of the alkanones or the ketone. So this is a ketone or an alkanone, and here we have an aldehyde, or alkanal. So if you take a look at it, the number of carbon atom here is 1, 2, 3. Hydrogen atom is 6, oxygen 1. Here, carbon atom 1, 2, 3, hydrogen 6 with 1 oxygen atom. So what I have here is propanol and here is propanol. They are all chain isomers. So with this now, in our next class, we'll take a look at the metamerism and the stereoisomerism. I believe this reach you at a very relaxed state of mind. Marry it up with your textbooks. If you have any problem, just drop it down in the comment section. Thank you and bye.